Okay, we've got a worked example here. This is the method of differences type of proof. It's called the method of differences. This is from the IAL specimen core pure paper. Um, Essentially, let's have a look at the problem. Okay, so prove that this sum, and this goes from for r from 1 to n. So obviously the first term is 1 over 1 plus 1 times 1 plus 3. So 2 times 4, so 1 over 1 over 8. Yeah. Um, is equal to this. Okay. Um, so Right, so and we've got to find the constants A and B. So a lot of these method of differences problems rely on use of partial fractions. Uh, in general, what we're trying to do is we are trying to express this as as the function, sort of two different instances of the function. Like this, kind of f of r plus one minus f of r. Okay, so so if we go through a partial fractions decomposition here, so we'll not go through the details of that because that's covered elsewhere. We're going to find essentially that this term is equal to this. All right, so and then when we write that out, okay, so let's just step through. We do r equals 1. We're going to get this. I said it was equal to an eighth. In actual fact, once we have written it as partial fractions, that comes out as a quarter minus 1/8, which is an eighth, obviously. So so that's sort of the trick. R equals 2 gives us that. R equals 3 gives us that. R equals 4 is that. Um, Now we can see from here that actually we're going to get some cancellation going on here. When we come to add up all these terms, then that's going out with that, that's going out with that. Um, we're also going to get that's going to cancel there with a term down here. Um, okay, so then we have to think about what happens at the end when we get to around the value of n, the other end of our limit. Then okay, so if we I think we kind of realize that we've got two terms here, so we need to go three back here. So these cancel. We're going to be including those. So we've got to expect to actually include those. So if we go back to n minus 2 and evaluate those, if we go further, then it won't matter because it will just we'll just see that they will cancel. Okay, and evaluate those. We're substituting n minus 2 in for r in this expression here, that expression. Okay, and we can see from that analysis, we get down to r equals n, that that's going to cancel with that. So we can see what's happening here is that that's going to cancel with this term up here. That's going to cancel with a term, not that term, but a term up there. So essentially, all we're going to be left with are those two terms and those two terms there. All right, so that is the idea. When we add those up, we've got four terms to add up. So if we put those together, we're obviously going to find a common denominator there, which is going to be n plus 2 into n plus 3, or 12 into n plus 2 into n plus 3. And so if we work that through, we're going to end up with this expression here, which is, of course, exactly what we're looking for, with A equals 5 and B equals 13. So that is it, basically. It's a kind of relatively straightforward problem in this particular case at least. Now, the question you might ask is, have we just been lucky here? You know, we've done partial fractions on this, and lo and behold, it's actually just given us something that we can use. Well, we're lucky that's come out something convenient. In general, it is possible to always write this kind of thing as a difference of two terms. Um, and and as such, we would be able to use the method of differences. However, it's not always very easy or very practicable to do so. So if you wanted to kind of understand a bit more about this, then you need to discuss study discrete calculus. Um, and find out a bit more. But for your further maths A level, then you're essentially going to be asked to do ones which work out fairly readily. Okay, so and that is basically it. Yeah, we can always apply it, but you're not going to get some of the kind of more obscure um, transformations that are needed. Right. Okay. So that basically is it. It's the method of differences. So this was from IAL's specimen paper. Hope that's been useful. And thanks for watching the video.